to answer and upload, right? So there will be some questions, very simple questions. Okay. The syllabus will be till not today's lecture, excluding today's lecture. The lecture before your vacation. After vacation, we didn't have any class, right? After this midterm break, Haridayan, this is the first class, right? So before that, whatever we have covered, that will be your syllabus. Today's lecture is not included for the test next week, right? All right. The following week, we'll have your soft skill test. Soft skill test, which means you will present very short on catalysis, right? I will give you the some topics in the spectrum. I will post some of the topics. Based on that, you will come up with a presentation of 2 minutes PowerPoint presentation. And that will be for your soft skill evaluation. It's the requirement for the university that you need to go through this soft skill. Whether you pass or fail doesn't matter. It will not be counted in your final grading system, in the final results. So simply you have to go through this soft skill test, whereby your confidence, your power of speaking, all these will be judged. So this is 2 minutes presentation, because you are 21 in number. 21 students, 2 minutes, 42 minutes. So it will be good for us for 1 hour class, right? We can manage it, hopefully, inshallah. That you have to present for 2 minutes. Can follow me? Any question on that before you start the lecture? I will give you the topics. Topics means some of that topics. I will post it in the spectrum. You will choose any one of these. As for example, catalysis in industries. Okay, zeolite as a catalyst. Your biological catalyst, right? So there will be some topics. You can choose any one of these, right? One topic, and you need to prepare for 2 minutes presentation. That presentation will be used for your soft skill evaluation. Can follow me? All right. I think no answer from you means what? Are you in front of your computer or not?
No question, Doctor.
You are good. I'm not sure whether other friends of yours, they are in front of the computer or just kept it on and just, doing some other things. Sometimes it happens, right? But
Doctor,
uh-huh.
regarding the presentation, is it poster presentation or slide presentation?
Slide presentation, PowerPoint presentation.
Okay, thank you, Doctor.
However, it's up to you. If you wish to present a poster, it's also well, no problem from my side, because this soft skill, this test will be to test your speaking power, your confidence, all these, right? So either it can be in the form of PowerPoint presentation of this subject, or any poster presentation. Up to you which one you feel comfortable or easier for you. I think PowerPoint presentation for 2 minutes would be good, because suppose you have chosen the title, that is zeolite as a catalyst. So you write that what are zeolites, means your the uses of zeolites, and in terms of catalysis where it can be used, right? Simply for 2 minutes it will be fine. Just few slides will be okay. Maybe four, 5 slides, because within 2 minutes, how many slides you can present? 4 or 5 slides, right? All right. Okay, let's start today's lecture. All right. Today we'll see that enzyme as the biological catalysts. So we have so far studied some of the metal catalysts, some inorganic catalysts also, like zeolite, and some of the homogeneous catalysts, right? All right. Besides that, we have another type of catalyst, that is enzyme as a biological catalyst. So enzymes can be used as catalyst in any biological reaction. It permits reactions to go at our body temp conditions, that is pH 7.4 at 37 degrees centigrade. It processes millions of molecules per second. So it's very specific, react with only one or a few types of molecules. These are called substrates. As usual, this one will follow the activation energy barrier. It will cross the activation energy and finally come to this, form this product. So it will reduce the path, it means your activation energy. It will follow a different path whereby the activation energy is reduced and the reaction is faster. Right? So enzyme catalyzed reactions will follow a shorter path than without using the enzyme, right? So enzymes change how reactions proceed. It will reduce the activation energy, makes it faster. All right. Now, so enzyme nomenclatures is that the name is based on what, with, or how it reacts. As for example, to react with lactose. Now, the enzyme is known as lactase. Ase is that at the end, it's that ase with this lactose. So it's that lactase. Understand? Suppose to oxidize glucose, we need an enzyme is called glucose oxidase. Glucose oxidase is the enzyme to oxidize glucose. Based on type of reaction, oxireductase, which means it will catalyze a redox reaction, oxidation reduction will occur. So based on that, we have oxireductase. Transferase, transfer a functional group. Hydrolase, catalyze a hydrolysis reaction. Lyase, add or remove to carbon-carbon double bonds. Isomerase, rearrange to form isomers. Ligase, join two molecules. Good. So enzymes, in fact, are typically used proteins. So yet only a small part are actually involved in the reaction. Right. The active site has two basic components. One is that catalytic site. Another one is that binding site. So it works in this way, like any lock to open by a key. So lock and key mechanism it follows. If you look at that picture, you will see that these two look similar and exactly same. That is your based on the substrate to fit in. right? And like any key, if we look at it, that is, if we have the lock, we have this type of arrangement where we need a key which will fit to this structure. So this is very specific, which means a substance of different structure will not be able to bind to these sites. So these are the binding sites, and these sites is that catalytic site where reaction occurs. So the enzyme will hold the substrate in these two places, holding. After that, the catalytic reaction will occur these sites. So this is that your total enzyme and the substrate where it's just fits together and work. So enzymes are often very specific. Each enzyme will catalyze only one type of reactions and often will only work with a specific substrate. As for example, urea, to convert this one, it will be hydrolyzed with urea will be hydrolyzed to form ammonia and carbon dioxide. We use urease as this catalyst. This is your enzyme catalyst, right? So urease has no effect on other compounds. It will be only used for converting urea to ammonia and carbon dioxide. Can follow? Okay. Reverse way, if you have this reverse reaction, we do not need urease. For ammonia and carbon dioxide to form urea, it will be in this. If you put this arrow sign this way, backward way, which means ammonia and carbon dioxide will form urea and water, right? At that time, we do not need urease, because that ammonia will be converted to urea in presence of carbon dioxide, right? So at that time we will have a different catalyst, that is not your enzymatic catalyst. That means the catalyst will not be an enzyme, right? But to convert urea to ammonia and carbon dioxide, we need this enzyme. So it's absolutely specific for some of the cases. So only reacts with a single substrate. A group is specific, linkage is specific, stereochemically specific. All these are the types of catalysts. That means it works. So if it's group specific, which means it will find the same functional group as, for example, hydroxyl group. So works with similar molecules with the same functional group. It may work in this way, linkage a specific way, that is, it will catalyze a specific combination of bonds, that is, linkage of these substances. So stereochemically specific, that means it will only work with proper stereochemical configuration. As for example, D dextrorotatory or L levorotatory form of glucose. So, okay, so enzyme substrate, how it works, that all of these steps are in equilibrium, whereby we get enzyme and the substrate forming enzyme substrate complex. So it will form a complex as usual. As we know that to get any product, we have an intermediate product, that's a complex, right? It's very unstable, and soon after the formation of this complex, it will try to form the product and get the catalyst out from it. So an enzyme product complex is formed. So transition state, it passes through this transition state, and it's a complex. Later this complex breaks down into the product, and enzyme is free. Enzyme is ready for another substrate to react with, right? So here are the products coming out from this enzyme and the your substrate. It's now separated out as a product, right? So if you look at it, that is active sites like this. If we have enzyme, suppose for converting the amino acid, so amino acids will form with the means will form a complex with this enzyme in this lock and key mechanism this way. Okay, so this complex, as we discussed, that's very unstable. Immediately it will try to form the product by releasing some water, and this enzyme will get out from this when the product is formed. The product, a peptide bond may form, and then we'll have this protein structure from this amino acids. So internal rearrangement looks like this, that this is that catalysis part is going on here, right? All right, so enzyme is made free and it can be used again, right? So enzyme is lock, as for example, this is lock like something, and key, we need to find a key, right, to feed it. So substrate is that key. Suppose glucose oxidase. Now glucose oxidase is that enzyme. Now glucose will come in and fit here, right? And it will be oxidized to carbon dioxide and water. So the substrate is okay. It must fit. All right. So it's that it's very specific, right? Other than glucose, no other molecule can come in to get the use of this glucose oxidase enzyme to work. So when this glucose oxidase enzyme is fixed as an enzyme, it fixed for converting glucose, not any other substance. All right. So at the active site may not fit substrate. If it is so, this is called induced fit theory, whereby site must change in order to form the complex. Sometimes if it doesn't fit, that means we need to have work with it so that it fits. So if it is so, in that case we call it induced fit theory, whereby we do some mechanism so that it fits. If it doesn't fit automatically. So effect of temperature on enzymatic reactions, we have, suppose our normal temperature in the body, if it is in our body, if it is working, then its usual temperature is 37 degrees centigrade. So exceeding the normal pH and the temperature ranges always reduces enzyme reaction rates. If we exceed that pH and the temperature of that optimum temperature and optimum pH, then our reaction will occur, but very slowly. It will reduce the enzyme reaction rate. So rate will be very high at that optimum temperature, as for example 37 degrees centigrade, or and optimum pH maybe 7.1 or 7.2, right? Okay, so effect of enzyme pH on this enzymatic reaction, as just mentioned, that is, as for example, pH 7.4 is good for this particular enzyme to work, so it will work at pH 7.4. Beyond this, above this, it will not speed up the reaction. The reaction rate will fall. So we need to choose the optimum pH and the optimum temperature for this enzymatic reaction to occur to get the best results. As for example, if we see, look at that optimum pH and optimum temperatures, which is not given here, but optimum pH are given for some of the enzymes. As for example, pepsin is found in gastric mucosa, where we find that a pH of 1.5 is good enough to convert this reaction, which means it's very effective at pH 1.5. Sucrase, it's found in intestine and the optimum pH is 6.2. At this pH 6.2, it works very good. Liver, there we have catalase. The optimum pH is 7.3. At that pH, it works very good. Beef liver, erginase, pH is quite high, alkaline pH, 9.0. Alkaline phosphatase, this enzyme is found in bone. The optimum pH for this is 9.5. If you see that this virus, your coronavirus, it works very good at pH, acidic pH, but it's killed or it doesn't survive at a higher pH of 8.5, 9 or 9.5. Can follow? It dies, it cannot survive. So it's recommended that if we take alkaline food during this COVID, it's good for us. If you take, suppose lemon, pineapple, mangoes, all these are good for killing this virus. And the virus doesn't survive at pH of 8, 8.5, 9, means alkaline foods are recommended. Oh. All right. So effect of substrate concentration for non-enzymatic catalyzed reactions, we have seen it previously that with this substrate concentration, the rate of reaction increases. So the rate increases if the concentration of the substrate increases. And also, if we increase the concentration of the enzyme, which means the catalyst, also it has the effect, it's also works that way. That is, for enzyme, if we increase the substrate, suppose glucose is converted by glucose oxidase enzyme, right? Now, this concentration of glucose, if we increase the substrate concentration, that means the glucose concentration, you will find that it will increase slowly and later it will be leveled off, which means rate will not have any effect after certain concentration. At that time, it falls flat, which means upon this after this certain concentration, the reaction rate will not be increased, rather it will follow the same way as it was the saturated point has reached, right? All right, so if you, besides that, if we increase the concentration of your catalyst or enzyme, it will have also the effect of increasing. A turnover number is used for this catalytic reaction, that means for this enzymatic reaction where enzyme is working as a catalyst. So the rate at which an enzyme transforms the substrate is known as the turnover number. So it's measured at the optimum pH and optimum temperature. At optimum pH, highest activity is observed of this catalyst. At optimum temperature, the highest activity of this catalyst is observed. That means for carbonic anhydrase, as for example, to convert this carbonic acid to carbon dioxide and water, the turnover number is 36 million. That means 36 molecules per minute can be converted, which means this one is the rate. With this rate, 36 molecules per minute, this enzyme can transform the substrate, right? Carbonic acid in this case, right? So this is the turnover number. This is one thing. And we have inhibitor in this enzymatic reaction whereby the enzyme will be inhibited by the substance. So inhibitors interfere with ability of enzyme to react properly with the substrate. So it will interfere. As for example, medicinal drugs, it will inhibit by inactivating an enzyme for this essential for enzyme which is essential to bacterial growth. So if we are affected by any virus or anything that will be propagated or accelerated with the enzyme, so our job is to deactivate that reaction by deactivating the enzyme, which means enzyme, if we allow that it will not work, then the bacteria will die. Can follow? So how to combat this bacteria? We have competitive inhibitor, which means this substrate, suppose this bacteria can get in to this active site of the enzyme, it will accept the substrate as well as any molecule that mimics that substrate, right? Anything if we find just that resembles this substrate, then it will fit with in this position whereby the substrate will not find any suitable catalyst to work. So it will die. Suppose if it is a virus, it will not be able to be active because the enzyme will not accept this one because we have added something just related to the structure of this virus. So inhibitor, it's that it will inhibit. So it competes with the substrate for the active sites. So there will be a competition between this substrate and the inhibitor. So if the inhibitor wins, the substrate will not get the opportunity to fit in this lock and key mechanism and work. So thereby it will die down. It will be killed. So this is the mechanism how drugs work. So sulfur drug, illnesses caused by invading microorganisms like bacteria can be combated using a competitive inhibitor called an antimetabolite. So this type of inhibitor is believed to alter the shape of the enzyme and greatly reduces the affinity for the substrate. One is that if we have competitive inhibitor like this is that making a competition, same type of structure. This can be, or if we have another mechanism whereby we will alter the shape of the enzyme so that anything would come to this enzyme will not find any suitable position in the enzyme, so it will die down. So this type of inhibitor is believed to alter the shape of the enzyme and greatly reduce its affinity for the substrate. As for example, any virus or any bacteria, anything, that enzyme will not entertain because we have changed the shape of the enzyme. So it does not compete with the substrate for the active site, and also it does not need to resemble the structure of the substrate. So by these two mechanisms, we can produce non-competitive inhibitor so that it does not compete with the substrate for the active site because we have changed the substrate, changed the shape of the enzyme. Suppose you have a lock and key, right? You have a lock. Now, if you change the lock, the people coming to open with that previous key will not be able to enter, right? So this is that mechanism we can follow. So it does not need to resemble the structure of the substrate. You have the key, right? I have changed the lock. Now you cannot enter. Can follow? So we change this way. We change the we do not change the key, but we change the lock. So non-competitive inhibition, this can be done with this inhibitor. Molecule will come and hit this, we will change the structure of this enzyme. So a non-competitive inhibitor can bind to an enzyme in many ways. If it binds somewhere on the surface of the enzyme, it causes a change in the tertiary structure. So if it like this, if something is embedded here, this shape will be different, changed. Suppose if we hit it like this, that this will be destroyed. The structure will be, changed. So the active site will no more be good for this substrate to fit. Right, fit in. So is that the substrate is inhibited this way because it cannot find to get into the enzyme, finding its right position, right structure, because the structure is now changed because we have changed this structure by adding any of this molecule inside this enzyme. This is that inhibitor, right? So this molecule is that inhibitor. It will change the structure of the catalyst, the enzyme. Thereby, the active sites it's changed. So enzymes are often regulated by the cells. Cells are several methods to control when and how well enzymes work. So this way, that means enzymes are often regulated by the cell. It's not like other catalysts. And these cells use several methods to control when and how well enzymes work. That we will determine this one, that part. Okay, so this way enzyme in fact works as a drug delivery. In the drug we use the drug in such a way that it changes the enzyme for a particular reaction to occur for a particular disease, like any bacteria, right? So that bacteria can find a good enzyme to propagate, to thrive, to live on. Now if we wish to kill the bacteria, what we need to do, if we change the enzyme, the mechanism of this means enzyme and the bacteria, how it reacts, if we make a barrier to that, then bacteria will die, right? All right, so summarization on these catalysts and catalysis. We have a quick look at that. Okay, so catalysis in industries. Why is catalyst so important? We have discussed this one. That is, without catalyst, many reactions that are common in the chemical industries would not be possible, or would find it's possible but very slow. So it cannot be recommended to use that reaction, to carry out that reaction in that way when we find that the reaction is very slow or it's not possible to occur. For that case, we bring catalysts. Catalyst will make the product formation very fast, At the same time, the yield will be more. This yield can be produced without using the catalyst, but very low and very slow process that is not economical. So for the production of ammonia, as for example, a very high temperature is required to break the triply bonded nitrogen bond. So we need a catalyst to help us to bring this temperature down. From a very high temperature, we bring it lower temperature by using a catalyst. So catalyst will help the reaction temperature from high to low, right? So catalysts accelerate reactions by orders of magnitude, enabling them to be carried out under the most favorable thermodynamic regime and at much lower temperatures and pressure. In this way, efficient catalyst in combination with optimized reactor and total plant design, these are the key factors in reducing both the investment and operation costs of a chemical process, because we have given an industry for profit, to get the product in the most efficient way, right? That means we should get more products and faster rates. For this, we bring catalysts. So catalysts are very important in the chemical industries. So catalysts are the workhorses of chemical transformations in the industry. Approximately 85 to 90% of the products of chemical industry are made in catalytic processes. Almost all of the industries are using catalysts. So catalysts are indispensable in the production of transportation fuels in all oil refineries in the world, in production of the petrochemicals, in production of the bulk and fine chemicals in all branches of chemical industries. As before I discussed, that is bulk production and the fine chemicals. Bulk chemicals, which means a lot of use of that particular chemical. As for example, sulfuric acid, nitric acid, we need a lot. But fine chemicals, these are the chemicals of restricted use. We have little use, so we do not need a lot of this. So if this type of chemicals are there, we call it fine chemicals. Based on our use, we do not need a lot in our everyday life. If this type of things, if we have a special type of thing, so these are the chemicals named as fine chemicals. It's not that in fine in nature, that is very fine, very soft, fine, very low your sizes. It's never like this. It's not referred to that. Prevention of pollution by avoiding formation of waste, that is your catalysts, are used to suppress the unwanted byproducts, that what we do not need. Thereby we save the your environment, that is it's related to pollution abatement. So abatement of pollution in end of pipe solutions, automotive and industrial exhaust, where we find at the end of this pipe, the exhaust pipe, we use this catalyst to convert the gases into harmless gases. Otherwise, harmful gases would enter the environment and create the environmental pollution. So, okay, I think if I get time, will it be very short? Let me close this one because I have some other slides to show very fast. Ah, close this one, close. Just 1 minute. 15 of us, 14 of us are the students are present. However, it's okay. Present now. Yeah. Can you see it?
Yes, doctor.
Okay, fine. Okay, let me go it very fast. Okay, three key steps, aspects of catalytic reaction, that is taking part in the reaction. It will change itself during the process by interacting with other reactants or molecules. So the altering the rates of reaction. In most cases, the rates of reaction are increased by the action of catalyst. However, in some situations, the rates of undesired reactions are selectively suppressed. Can follow that undesirable reactions can be suppressed by this catalytic reaction. We discussed it before. If you look at the previous slides, you will find the examples of that. So returning to its original form, that means after reaction, we get the catalyst to use it again. So it's reborn. In practice, a catalyst has its lifespan. It deactivates gradually during the use. Oh, so we need to activate it again and use it again. So general requirements for a good catalyst is that it should have the catalytic activity, catalytic selectivity, and catalytic stability. So catalytic activity is that a catalyst should be able to pass through the catalytic cycle multiple times. Higher the number of times the catalyst passes through this cycle, higher is the activity of the catalyst. That means the more we can use it, it's better for us, of course. If we use it once or twice, after that we need to change again. So that should not be our choice, right? So the number of times that a catalyst can go through, what is this? Why this? What is this? This came back. Just 1 minute, please. Close this one. Okay. What a disturbance is that? How it appeared, Okay. Just 1 minute. Just 1 minute, please. Okay, done. Come back to this. Okay. 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 So we are here, right? Okay. Can you see the slides? Can, I think. If
Yes,
you could,
Doctor.
Yes, Doctor.
yes. All right. Thank you. So in homogeneous system, the turnover frequency is defined as the number of molecules of substrate converted per second, which is the turnover number in a certain period of time. It depends upon the absorption of the reactants on the surface of the catalyst. So chemoabsorption is the main factor governing the activity of the catalyst. The bond formed during the absorption between the catalytic surface and the reactants must not be too strong or too weak. We discussed it before. If you can remember that our catalytic surface should allow the products to leave the catalytic surface. Otherwise, new reactants will not be able to come to this catalytic surface, right? So it should not be too strong. The catalyst and the product formation, right? If this bond of between the product and the catalytic surface is very strong, then it's difficult to leave the for the product to from the catalytic surface. That means it should not be very strong or too weak in between. The purpose is that once the product is formed, immediately it should leave the catalytic surface so that more reactants can come in and the catalytic process can go, right? So this is that requirement for this, for choosing the catalyst. So catalysts are highly specific compounds. They have an ability to direct the reaction to yield a particular product. Previously we have discussed also that if we choose a catalyst, it will give us one type of product, right? If we change the catalyst but the reactants are same reactants will give two different products based on the catalyst used. We also discussed it before in the slides. If you remember now, you can, okay, it's fine. If it is not, you will see the slides. The reaction with the same reactants but with different catalysts may yield different products. So this is termed as selectivity of the catalyst. So catalysts are highly selective in nature and catalyst must be very stable. A good catalyst should resist to deactivation, which means it should not be deactivated very fast. It should be continuing giving the service. So deactivation is not desired. It must remain activated all as long as it can be. So it's that our purpose of choosing this catalyst will be to see the stability. It will be another choice for us to choose the catalyst. So a good catalyst should resist the deactivation. It should not be deactivated so easily, right? This should be our aim in choosing a catalyst. So it can be deactivated by impurities like lead in petrol. It poisons, right? And thermal deactivation all can happen. Okay, all these are the factors, right? So a solid catalyst should have reasonably large surface area needed for the reaction to go. So this is usually achieved by making the solid into a porous structure, right? So anyway, so catalyst should lower the activation energy. Of course, we should look at that, right? Anyway, so these are the things we have already discussed. Acid-base catalyst, enzymatic catalyst, photocatalysis, and electrocatalysis. That is, examples of these are nickel platinum for hydrogenation reactions, iron for Haber-Bosch process for this ammonia production, right? So palladium for catalytic converters, rhodium also used in together with platinum can follow in the catalytic converter. If you look at it, you'll find that platinum with rhodium, platinum with palladium. Both all these are bifunctional catalysts. Al2O3 alumina is also used for dehydration reaction. Vanadium pentoxide used for contact process for sulfuric acid production. So all these are the applications of the catalysts. All right. So I think till this end, three main types: heterogeneous reaction, homogeneous, and enzymatic catalysis. All right. Thank you very much. Do you have any question?
Doctor, for next week test, the topic that will come out until Zola, isn't it?
Yes. Until the last lecture, not today's lecture. Before Hari Raya, which means 10th week, I think week 10th, lecture 10th lecture, right? 1 to 10 lectures. If you look at in the spectrum, you will find that lecture 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th. 10th week, 10th lecture we had, right? After that, you have semester break. After that, we had your last week Wesak day. Last means your 12th week, 11th week. Yes, so today is that 12th week, right?
Okay, Doctor, thank you.
I will post you. I will say your in the spectrum. I will give you the information for this soft skill test on 14th, week 14th. Huh. So next week will be week 13, right? And week 13 we'll have the test. Anything, if you have any question, please email me or send me SMS or call me, anything. All right. Okay. If there is no